Snowflake, house of your data. Why Snowflake, and what differs Snowflake from other platforms, other tools? Snowflake was created from scratch. It had no history, no dependency on existing customer base that you need to support. It was created from the scratch by ex-Oracle developers who started from the idea, not from the existing customer, but from the idea how exactly it should work, what exactly we are trying to achieve. And the idea was to create a platform that meets all the needs from different users, different business cases, and one platform for all data management, because they already felt that business users, data scientists, data engineers, they all have slightly different expectations of the tool. And all the core features like security, roles, row-level security, databases, schemas, all those are in place. We will not go deeply into that because, to explain you that Snowflake has security roles, and every tool has security roles, it makes no sense to waste your time. And it manages SQL and Python queries by default. Any workbook you will create or any query you will run, you just choose either you use Python or SQL. And I think that those two are the main languages that in our days are used for data transformations. Number of users around data are really growing, and new scenarios are coming every day. Why report is not enough, and in our experience as well, we meet more and more requests that the report is fine, the report works well, but I need to get to the data. Why? First of all, I need to create my own report for a very specific purpose, and I know exactly what I'm looking for, because in nowadays, analysts and even some business users, they already know the SQL. They already know the tools, and they can do some of the reports or insights by themselves, and explaining that to the data engineer who will just rewrite the query that you already provided makes no sense. So they're asking for access to the data, and we have the business case that we are developing where 600 users are using Snowflake. 600 users are accessing to the data, which is a way different level that we had maybe 20 years ago, where only the data engineers, that 3 of them, were accessing the data. Automated reports. Someone is building or implementing tools that for alerting or for outside distributing or for any other reasons creating reports, something like, and printing is does, but with additional functionality. So they're asking access to the data. Additional tools like budgeting for the facts or last year, they always need the data. Even connecting Excel to the data, I don't think Excel will ever get out of the picture when we are talking about data analytics, because there is no other tool better for modeling the data. In some cases, we have experienced that even ERP that we were collecting data from asks us to push back some of the statistic and the data. Like in this example, what I wrote, manufacturing company wanted to have an item card, cost split by all the manufacturing processes and adding the cost of the work. Because in ERP, they can see the cost of material, but they couldn't see what is the cost of work. And it is recalculating every day using the new price list of the materials. And every day you can see that new statistics. And when the sales are discussing with customer or negotiating the price, they always know what is exactly the cost of the future production. And CRM applications, they are always hungry for actual data, because just to have the customer card in CRM, it's not complete. Architecture in Azure without Snowflake. That's actually how it looks in our cases as well. It's a sign-up, so we have SQL databases, we have blob storage, and when all those scenarios that we were discussing in previous slide, when they are starting to ask for the data, you're starting to provide them different views. For example, if we are storing the staging data just in a data lake, and the business asks, we need to evaluate how exactly the data is filled in, for example, customer cards. Is there any customer cards that don't have price lists attached? Is other customer cards without manager and without address? And they want just to access the data and query it and evaluate the quality of the data. And in this case, we are giving them access to the blob storage. And blob storage, I need this CSV to somehow manage. And for other data, it's in SQL. For other data, it's in a signups. So this mess is exactly what Snowflake was trying to solve. And any need for the data, now it's in a Snowflake. If you need a report, that's a Qlik. If you need data, that's in a Snowflake. Snowflake platform, it's very good to understand how exactly it works and why it's different from some of the other tools. First of all, in a center layer, we can see the optimized storage. This storage can be in Google Cloud, can be in AWS, in Azure, and that's just the storage. It is separated from the rest. It's where the data lives. On top of that, we have a multi-cluster compute layer, elastic compute layer, which means the compute engine is totally separated from the storage. Not like in SQL Server. It's separate engines. And the last layer, the light blue, it's all the services that end user is seeing. It's the studio where you write notebooks. It's the containers where you put your ML data models. Everything that a user is accessing is the last layer. Performance. That was one of the, I already mentioned, key points for us, that this compute cluster compute engine is very, very fast. It's like to make a transformation for 1 million rows, for 1 million, like connecting 5 tables with 100 of million rows and doing some calculations. It took for us 1.5 minutes. And in other tools, that was 15 minutes. So just to proceed to the 100 million data, it's nothing. What does it mean, this elastic multi-cluster compute? That means that on the same data, we can run three different queries or transformations on the same data, on the same tables. We can run three different transformations with totally different compute power. One is quite simple data. It uses extra small compute engine. Data scientists, they always need a lot of computing power that's a medium. Marketing also using a small one. And it's not like in a SQL server that you will be suspended until data scientists will not finish, the rest are waiting. They all run in parallel. And as Snowflake states, they support only unlimited concurrent users, concurrent queries on the same data. And with Snowflake, you pay only for seconds that you are using this compute engine, seconds, not even the hours, but seconds. And sometimes it makes even sense to run bigger queries on bigger engines that cost double, but the query time is 2 times less, so in the end you pay the same. And data discovery. Data discovery is the same scenario that I was telling about business that is accessing actually. We have customer that has entities in 20 different countries. For them to find out how exactly, what is the situation in the raw data, just in the raw data, they need to connect to different servers, different companies. And when you gather everything in one place, they immediately ask, can I get the access? I want just to see what is going on in the raw data. That's the data discovery. But in data lake, it's very difficult to have good quality data discovery, because data lake is reading all the files, then looking in that file, particular data that you are looking for. And in this case, it's all the queries run very long. Almost to process all the data and to get only the last month, it's almost the same time. That's why the data lake is one of the worst tools for data discovery. Elastic computer, yeah, you can scale it out, scale it up, and multi queries. Maximizing cost and efficiency. This is also interesting because in signups, the same. Of course, you can. They are charging per usage, but what is the usage? You get almost in the end, you get an invoice. So you know that you were running 200 hours and you have run 30,000 queries. But in Snowflake, you can see every query. You can get consumption by data warehouse, by user, by each query. How much exactly each night costs this query for you. So you know exactly where to optimize. You can set up a budget for each data warehouse, for each user, and you can get alerts if something is getting out of control. Micro-partitions, it's very important difference from other tools, how they are storing the data. This is one table, and it is stored in different micro-partitions. Those micro-partitions are from 50 megabytes to sometimes, if there are 10 terabytes of data, then up to 500 megabytes. But usually it's 50 megabytes partitions. And what it gives to us? Each partition actually can have a link to different tables, which means in Snowflake, they say data are stored only once. And in Snowflake, it's true. If I downloaded the data from ERP, for example, and I have the table, I can do a clone of that table in seconds, and they will not duplicate the data. They will create another table with link to the same micro partitions. And visually, actually, how it looks on a demo environment in our case that I created, I just write the code that create or replace database, whole database demo 2, clone from PC dbt dbt. dbt. And it took query duration 3 seconds. It took 3 seconds to create that new database. Which means even in Snowflake says, even to clone the terabyte of the data to another database for testing purposes or for any other purposes, it takes seconds. And it gives you additional possibilities to work with data. Sometimes you can create a clone of data, set up a special security and publish that to the special group of users, because they have the certain task and it's not permanent, it's just for 1 month. So very, very easy to do that. Another feature that also is connected to those micro partitions, it's time travel. I have a table, VC. It's from Hansa, I think. And number of rows in this table is 167,000. So I select the top 100. Okay, nothing interesting for me. And I just truncate. I truncated that table. And when I run again, select top 100 from the same table, it's empty. And now I realize that I'm quick in action and only then thinking, I need that data. Actually, I need that data. How can I get it back? I can select that data with timestamp. I can select that data with timestamp like 1 hour ago. How that table looked 1 hour ago. And I see the result. It's just to the same query, select top 100, I added a timestamp. And depending on level of Snowflake, what you will choose, standard or enterprise. Standard is holding the data for 1 day. Enterprise is holding all versions of data for 90 days. Which means they are not deleting the micro partition that we were talking about. They were just deleting the link to the table, but micro partition stays. And you can restore that at any time in 90 days. If that would be dropping the table, I can just write undrop the table. It's like, it was like, wow, I can undrop the table. And yes, you can undrop the table. It takes 60 milliseconds to restore the table. In this case, because I was just truncating it, I'm filling it back with data from certain point of time. And again, it took 1.6 seconds to fill back 170,000 of rows. Yep, now I have the data back. So these were the key differentiators for us to choose Snowflake: the performance, how fast it is, the possibility to run different engines on the same tables, different transformations done with different speed. So in all the cases we have easy dimensions that will processed in 10 minutes, and then we are waiting for 3 hours for the big fact table to be transformed. And in this case, we can shorten the time, and especially in Business Central, where all the cost posting are done just before the night ends, you sometimes have a shortage of the time. And the last thing, Snowflake, of course, it has AI and everything that is needed for AI. It even has this LLM functions, and you can create your own ChatGPT. And of course, it has containers where you can store your models. And by evaluation of experts, Snowflake is very high in the chart. how it is evaluated. So you can be sure that AI will be handled here as well.